Okay, so when we are looking at proportion, we are looking at if one thing goes up, how does it change another thing? So often what they do in your GCSEs is they will use P, K, and Q. So we'll make P purple. So they'll say something like P equals, we'll do K in, what color? I used red. P equals K and Q. Okay, so this is direct proportion, because if, say, P was 10, and let's just make K 1 for now. Then if Q, that would mean that Q is 10, right? Because 1 times 10 would be 10.
Oh, yes.
But yeah, so if P was doubled and K was the same, because K is usually the constant that we have to find, and K remained the same, then Q.
Wouldn't Q be 20?
That's right, exactly. So what's happened, if one's doubled, the other's doubled. So it's like direct proportion. So if we would look at it as a graph, as P goes up, then Q goes up as well in the same proportion. So, and that's the first thing, is now we understand that direct proportion means that as one thing goes up, the other thing goes up as well. So we notice that this equation here that you have to kind of know, P equals K times Q. The Q and the P are on the same, so they're both on the top. So the way they would ask that in a question, I'm going to do this on another. Actually, let me do that here. So they'll say something like P, smaller space. P is directly proportional to Q. Oops. To Q. And they'll say P is 10 and Q is 5, let's say.
So then would that make K2?
That's right. Yes. Good. You've already done it. Yeah. Because our P would be the 10, and then the Q would be the 5. And then, as you say, you would actually work out P to be a K to be 10, because you'd say, well, we'd use this equation. I'm going to write the equation out. I'm just going to plug it in. So P is 10, that purple one, and then K. So this is how you would set it out. Is something that we have to solve. You'd already worked it out in your head. 10. And so if we divide both sides by 10, then K is equal to 2.
Okay. Yeah.
And then the second bit would be, they would say, what is what is P when Q is 3? That would be so what is P when Q is 3? And we would then, now that we know now that we know what K is,
Would the P stay the same?
yeah, so our P kind of does this. We kind of, what is P? So we use this equation P, but the K is the thing that doesn't change. So K is like our constant. So the first part of the question is always working out what K is. And so we plug in K and we plug in then Q, which is 3. Well, because they told us Q is 3, yeah. Put that in, and then we get P to be 6.
Oh, okay, yeah.
P equals 6. Because if K is 2, basically K is the proportion value. So we notice that 2, if K is 2, it's essentially doubling it. So when Q is 3, P is double that. So now I'm going to go and say, well, okay, so if we understand this concept, you'll notice that in your exams, they won't probably have it as simple. They'll say something like P is directly proportional to Q squared. Q squared. And so this Q value, because it's Q squared, when we're working out our K, we have to actually put in, because Q is, I haven't changed anything except the fact that it's proportional to Q squared, then this would be essentially squared here when we work out K. Okay, so I'm going to erase what we did and see how that would change the answer. So this all goes, because what's the first step? The first step is always finding what K is. Well, not always, but it's mostly always finding out what K is. And so we would do the same thing, except the only difference is instead of putting Q, we actually put in Q squared because it's directly proportional to Q squared.
Yeah.
So then we put 10 as, but why did I put 5? P is 10, Q is 5. Oh, I would have to say, yeah, so I'd have to put a 5 in the squared bit. Okay, so first step, working out K. And when we say P is 10, when P is 10, Q is 5. Okay, so the first step, figuring out what K is, we sub in our initial values of P and Q.
Yeah.
Cool.
Okay.
Perfect. And so we get K.
It's 5 squared.
Perfect. Yeah. 5 squared is 25. And 10.
Wouldn't it be? Trying to think about signs.
So we have to kind of divide by 25 on both sides to get K.
Yeah.
Okay. So 10 over 25. We can stick that in our calculator, but we should get, if we times 25 by 4, we get 100. 10 times 4 is 40. So 40 over 100 would give us 0.4. So our answer for K would be 0.4.
Then 0.4 times 25 is 10.
Right. Okay, so that's right. Good. So that's the first step, figuring out what K is. So now we know what K is. We would then, the next step is to figure out what is Q, what is P when Q is 3.
What is P when Q is 3? Okay.
So then we say P equals, and now we know K was 0.4. So you see that the numbers are a bit trickier often when they make it Q squared, and they can even make it harder because they can say directly proportional to say something like Q plus 1 or Q squared, so that it does get a bit trickier, but this concept is always the same. First one K, and then you can then find Q or P, depending on what they ask for. So what did we say? They said Q is 3 this time.
Yeah.
So it's 3 squared, isn't it?
Yeah.
So now that I would just stick in my calculator because it was 0.4 times 9. So we get 3.6. 3.4, 3.6.
3.6.
Okay, good. Yeah. P equals 3.6. Okay, so that's direct proportion.
Okay.
Same side, same, both on the top. So inverse, we know is going to be a little bit different. So I'm going to keep the direct proportion equation there. Okay. Okay, I think what I'm going to do is I'm going to do a new video for inverse proportion. So this I'll just send to you as direct proportion.
Okay.
Then I'll do part 2 for indirect.